What if controlling a drone was as simple as just telling it where to go? Welcome to Summarize Science, where we break down the latest research. Today, we're looking at a paper called C.Point Fly, which introduces a groundbreaking new way to give drones instructions using everyday language. The goal is to create a universal navigation system that works in any environment, with any instruction, without needing special training. Imagine telling a drone, "Fly toward the person with the green shirt," and having it immediately understand and start moving, even if the person is walking. Or giving it a more complex command like, "Fly to the cone and then the next one," for long-distance tasks. This system, called SPF, can do exactly that. Traditionally, teaching a drone to do this is incredibly difficult. You'd need to collect massive amounts of training data showing the drone what to do in every possible situation, which is slow and doesn't adapt well to new places or new commands. The brilliant insight behind SPF is to not treat this as a flight problem, but as a pointing problem. They use a powerful, pre-existing AI called a Vision Language Model, or VLM, which is already an expert at understanding images and text. When you give a command, the VLM looks at the drone's camera feed and simply outputs the pixel coordinates of where to go next, essentially pointing at the target on the screen. This simple point is then converted into 3D movement commands for the drone. The process repeats continuously, allowing the drone to create a smooth path and even follow moving targets in real time. It's also clever about how it moves. The system has an adaptive speed control, meaning the drone will take big, efficient steps in open areas, but slow down for smaller, more careful movements when it gets close to the target or obstacles. So, how well does it work? The results are staggering. In simulations, SPF achieved a 94% success rate, while a comparable leading method only managed about 29%. And in the real world, it was the same story, with SPF succeeding over 92% of the time, while another popular method failed almost completely, succeeding just 5% of the time. These charts show just how much better and more reliable the flight paths are. Here you can see a real-world comparison where SPF's trajectory is smooth and direct, while the other methods struggle or fail entirely. So let's recap the breakthrough here. By leveraging existing, powerful AI models and reframing the navigation problem to be about pointing instead of flying, the researchers created a system that is incredibly effective without any task-specific training. This is huge. It could dramatically lower the barrier for using drones in complex tasks like search and rescue, automated inventory, or even advanced filmmaking. Essentially, anyone could direct a drone with just their voice. While the system isn't perfect yet and can have delays, it's a massive step towards truly intelligent, autonomous drones. Thanks for watching Summarize Science.